D, E, F are respectively the midpoints of side AB, BC, CA of triangle ABC. Find the ratio of area of triangle DEF and ABC. Okay, I understood nothing. Without the diagram, it's hard to imagine. So let's draw the diagram, right? So we're talking about midpoint, so I'll draw a big triangle. It helps. Don't draw an equilateral triangle. Never draw an equilateral triangle. 1, 2, 3, 4, 5, 6. So that's my midpoint. Okay, let me write what they asked. What they given. So we have triangle ABC, and midpoints of AB is D, B, CA is F, and again this is a midpoint and stuff. So we have, okay, that's not the so we have this. Okay, looks correct. And this are D, and this is BC is E, and this is F. So find the ratios of DEF and ABC. We need to find those ratios. So how do you do this? For that, we need to prove that this Chotu triangle is similar to the big triangle. Right? That's how you find the ratios of the areas of triangle. So we have to prove them to be similar. So since they are midpoints, I can do one thing. What is that? I can prove that the opposite sides are parallel. How does that help? That helps in talking about the angles, right? When things are parallel, by default, you can talk about angles. That's the power of what to tell angles, right? So let me do that. So when things are parallel, so how do you prove that they are parallel at first place? So they're given that D, E, F are midpoints of AB, BC, and CA. Therefore, the ratios will be equal. That is, AD by DB will be equal to 1 by 1. AF by FC will also be equal to 1 by 1. DE by EC will be equal to 1 by 1. So basically, all of them are equal to 1 by 1. Right? Because we have this side by this side is equal to this side by this side, which is equal to this side by this side. The lengths will be equal, na? This by this, their lengths are equal. If this is 10 centimeter, D to B will also be 10 centimeter. And D to A is also 10 centimeter. So this ratio is 1 by 1. If this is 12 centimeter, this also will be 12. If this is 14, this also will be 14. If I divide them, we get a ratio of 1 by 1, is it not? Because they are midpoints, as simple as that. So since they are midpoints and the ratios are equal, by converse of PPT, I can conclude that DF is parallel to BC. So I already marked it. Then the next thing is EF is parallel to AD. EF is parallel to AB actually. Anyways, that is also correct. And DE is parallel to AC. And this entire thing is equal to 1. Right? And now, since they are parallel, so see, this is a quadrilateral. So since the quadrilateral has opposite sides to be parallel, what does it help us? Think about it. Consider quadrilateral DFEB. DFEB as opposite sides are parallel from 1. Right? We can tell, what can we tell? DFEB is a parallelogram. Since this is a parallelogram, we have angle DFE is equal to angle P, right? Opposite angles of parallelogram, and also this side is equal to this side. That is, let me write it in different color. FE is equal to PE is equal to X. This is my equation A. This is my equation first. So all this is helpful. Similarly, we can prove D, okay, these two are equal. DFCE, DFCE is a parallelogram. Therefore, angle FTE is equal to angle C. So this is my equation second. And also DF is equal to FE. So even the opposite sides are equal. DF is equal to EC, sorry, is equal to X. This is equation B. And I forgot to write the reason. We can write it over here. Opposite sides are equal in a parallelogram. If not, opposite sides of parallelogram, even that line, single line is enough. So now we are set. So we now have a clear look. We just proved that two pairs of angles are equal between those two triangles, and proving that they are similar is not a big deal. So all we have to do now is just tell in triangle ABC and triangle TEF. So we can tell that triangle ABC is similar to triangle E. B is equal to F and D from which two equations? From first and second by AA similarity criteria. We wrote the reason and whatever we had already proved. Since these two are equal, then we can talk about the ratio. Therefore, area of triangle ABC by area of triangle EFT is equal to BC square by TF square. So BC is nothing but BE plus EC the whole square by DF square. So now we are looking at substitute from first and second. That is the value of X. First and second talks about, oh sorry, this is A and B. A and B, yeah, not first and second, A and B. Equation A and B talks about the sides to be equal to X. That is, if this is X, then we have this to be X and X, so 2X basically. This entire length is 2X, so 2X the whole square by X square. So this is 4X square by X square. So X square gets cancelled. So this is 4:1. And that's our answer. We found the ratios of those two, area of those two triangles. So basically we're telling that this big triangle is 4 times this small triangle, right, in terms of area, right? So now you can pause and have a look. One small note, if they allow, you can do the same question with midpoint theorem and half the answer is done. Directly you can write the answer, but again, it depends on what the rules and regulations are. If you can use your 9th grade proof and theorems, if so, you can directly do this. If not, this is a bit lengthier version of the other answer.